Hello, everyone. My name is Mandy Bankson. I want to welcome you to the Pyramid Lake Paiute Tribe Triennial Review Public Workshop. Just wanted to let you know that this meeting is being recorded. The focus of this meeting is a technical one. It's going to focus on the outcomes of the Triennial Water Quality Review and data analysis. There will be an opportunity to ask questions at the very end of the meeting. So if you do have technical questions, you can either enter them in the Q&A box at any time. You can hit *9 if you're calling in, or you can raise your hand at the end of the meeting. Just also wanted to let you know there will be opportunities for public comment coming up at the public hearing on August 2nd. There are also opportunities to submit public comment at any time before August 3rd, and Aaron Bill will be providing information on how you can submit those comments. So with that, I would like to turn the technical presentation over to Aaron Bill, who is the Water Quality Manager at the Pyramid Lake Paiute Tribe.
Hi, Mandy. Thank you for the introduction, and welcome everyone to this public workshop as part of the Triennial Review of Water Quality Standards. My name is Aaron Bill, Manager of the Water Quality Program under the Natural Resources Department here at the Pyramid Lake Paiute Tribe. We are operating under funding from the Environmental Protection Agency and the Clean Water Act, Section 106, and in conjunction with SWCA Environmental Consultants, the Desert Research Institute, and the University of California, Davis. Here are the panelists assembled for today's discussion. Once again, my name is Aaron Bill, and joining me today are Jim Brock and Alan Havart from the Desert Research Institute, and Susan Mortensen and Mandy Bankston from SWA Consultants. Mandy will act as a moderator for today's workshop. Also here are Jeff Schladow and Sean Trommer from the University of California, Davis. And finally, Jennifer Nguyen is here to provide technical support for today's meeting. We are here to discuss proposed changes to the Water Quality Control Plan. But first, I want to remind everybody of the public involvement opportunities still available in this process. A public hearing is scheduled for August 2nd at 10 a.m. on the Zoom platform, where you can register as a participant for that event on our website, www.plptwq.org/triennial review. We also have our public comment period open until August 3rd via the email address shown on our screen, plptwaterquality@swca.com. Please take the time to submit your questions or comments to the address listed on the screen. Once again, plptwaterquality@swca.com. Thank you for your participation. The agenda for today is as follows. We'll start with general information on the Clean Water Act, on water quality standards, and the need for the triennial review process. Next, we'll go over background information of the Pyramid Lake Paiute Tribe, of its role of environmental manager of the natural resources on the reservation. Then, we'll discuss additions and revisions to the 2015 Water Quality Control Plan and the data methodology used by the Water Quality Program and its partners. We'll talk about EPA recommended criteria and the associated materials for promulgating new water quality criteria, and then we'll explore the technical aspects of certain parameters during this triennial review. First, recall the objectives of the Clean Water Act: to provide a quality of water to protect and propagate aquatic and wildlife, and for recreation. Under the Act, states and tribes are enabled to determine the uses of a water body to be protected and promulgate water quality criteria to ensure that those uses are protected. And enact anti-degradation policies to maintain an already attained high water quality character. The Act also requires that states and tribes review their water quality standards and to hold public meetings to discuss revisions to their water quality control plans. Tribal management of Pyramid Lake and the Truckee River precedes the Clean Water Act. They maintained a balance of the natural conditions with the established uses of the people. Withstanding upstream diversions and the effects of climate change, the watershed requires a coordinated effort of conservation to balance itself, which, to be fair, the effort is still ongoing. In the early 1980s, the Pyramid Lake Fisheries Program began lake surface water monitoring activities. Later, the tribe gained approval for a Clean Water Act Section 106 monitoring program and established site-specific water quality criteria according to the findings of the Limnological Research Group Lake Study in the early 1990s. In 2007, the tribe received treatment as a state status for Clean Water Act Sections 303 and 401 certification authority. In previous triennial review efforts, the water quality control plans that was promulgated in 2008 and then later revised in 2015 ultimately gained tribal council and then EPA approval. Tribal monitoring efforts began with a single program in the Pyramid Lake fisheries. However, over the years, those efforts have increased to over 2 departments and multiple programs. The Tribal Water Quality Program gathers its data through a series of program activities. First, we monitor water quality on the Truckee River with monthly field monitoring and grab sampling, on which we perform nutrient analysis for dissolved reactive phosphorus, total phosphorus, ammonia, nitrates and nitrites, and total Kaldol nitrogen. We also do continuous water monitoring with our YSI XO3 multi-sensor sondes. We also monitor and analyze stream water samples, wetland water samples, and spring water samples. The Water Quality Program also conducts stream and river bioassessments annually. We also periodically monitor for metals, E. coli, toxic organics, macroinvertebrates, and cyanobacteria. All of these activities go into our data analysis activities conducted for this triennial review process. Now we'll go over an overview of the Lake Tahoe Pyramid Lake watershed. Pyramid Lake inflows come from Lake Tahoe via the Truckee River, and as a desert terminal lake, water only leaves Pyramid Lake through evaporation. Upstream water divisions negatively impacted water conditions upstream, and due to the historic and hurtful natures of these diversions, the tribe set up sites where it monitors water quality conditions at its monitoring stations and utilizes the compiled data sets to determine how well its environmental management is performing. Here are the sites of the monitoring activities that the tribe performs regularly. Continuous monitoring stations take readings every 30 minutes at Nixon and Wadsworth. Their locations are donated on the map with the bright yellow arrows. We also regularly monitor 5 sites along the Truckee River, whose locations are denoted by the red circles on the map. Also, Pyramid Lake Fisheries conducts monitoring and sampling duties on the lake, most specifically at Station 96, which is named because it's 96 meters deep, which is one of the lowest points of the lake. We use all of these activities to further our data analysis in the triennial review process. Now, we'll discuss additions to the water quality control plan, beginning with water quality criteria found in the EPA's Model Water Quality Standards template for waters on inland reservations, known hereafter as the tribal template. The tribal template was published in 2022, February, to help tribes with little or no experience with water quality monitoring activities to jumpstart their programs. The criteria found within the tribal template represents EPA approved criteria that has been promulgated since the publication of the 2015 Triennial Lake Paiute Tribe Water Quality Control Plan. Also added within the control plan was a function which describes the aluminum criterion, which is based on conditional inputs of hardness and dissolved organic carbon, excuse me. Additional information included into the water quality control plan includes background information of the previous triennial review process held in 2015. Also included was a section to the implementation section found on page 40, which describes the importance of flows to aquatic diversity and for enhancing water quality. And finally, a series of recommended water quality analyses were recommended to the monitoring section on page 41. Further additions to the water quality control plan include a section on TDS to the site-specific scientific justification section. And what we did was we added a section that encouraged a coordination with upstream operators to reduce TDS loading, and also specifies further studies with the effects of total dissolved solids on other water quality parameters. Additionally, additional site-specific scientific justification was provided to the phosphorus section to reflect updated understanding of the phosphorus dynamics on the watershed. Further revisions include adding the term exceedance to the definition section. We also included edits and additions to improve readability and improve grammar. And we also added the Triennial Lake Paiute Tribe Water Quality Ordinance to the appendix for ease of reference within the sections. Now, as we go into the technical topics portion of this presentation, I want to talk about our data analysis that we conducted with internal tribal data sets. First, we looked at water quality exceedances along the Truckee River. And what we found is that there are certain parameters that show exceedances that can be described as more than just temporary. For example, DRP, or dissolved reactive phosphorus, was found to be an exceedance of over 75% of the sample monitoring, as well as temperature, total dissolved solids, and turbidity showed exceedances. It should be noted that temperature was found to be a seasonal impairment. I also want to point out that in the tables that we made an effort to list the sites so that they flow from upstream to downstream, which you'll see going from left to right in the tables. Data analysis of Triennial Lake sites showed that dissolved oxygen parameter was found in exceedance of over 25% of the monitoring instances, as well as there was some slight impairments to total dissolved solids, which was set at 5,900 milligrams per liter, as well as total dissolved solid total dissolved solids, and DRP, dissolved oractophosphorus. DRP was shown to be in exceedance in the full water column, not just the 0 to 20 that we identified. So now I will pass it off to Jim, who will further elaborate on some of the technical aspects of these select parameters. Go ahead, Jim.
Hi, everyone. I'm Jim Brock. I'm an aquatic ecologist at Desert Research Institute in Reno. Today I'm speaking from my home in Boise, Idaho. Next slide, please. Total dissolved solids is, to define it, is the combined content of all inorganic and organic substances dissolved in a liquid. And it's approximately equal to salinity. The sources of TDS in the Truckee River Basin and Pyramid Lake include the following list. The precipitation, rainfall, has a snow, extremely low content of TDS. There is a little in it. When water becomes in contact with soils and bedrock, it can dissolve solids from the soil and rock and gain in TDS. And this especially happens in bedrock or soil systems that are high in salinity. Another source can be groundwater pumping. As you pump water from the ground, it can have a higher TDS than, say, for example, the river. There can be seepage or upwelling of groundwater into the Truckee River that contributes dissolved solids. Thermal springs can have actually very high concentration of TDS. Urban area runoff that may be collected, for example, in storm drains or tributaries in the Truckee Meadows can have relatively high TDS content. Runoff from agricultural land, like in an irrigation return flow drain, often has elevated TDS levels. A primary source of TDS in an urban area is wastewater effluent. This includes the M&I, municipal and industrial uses. And so when you think about it, anything that basically gets released into the wastewater stream from a home, for example, the salts in it eventually end up in Pyramid Lake. So if you put salt on your popcorn and then it goes down the toilet, and eventually it will end up out at the lake. So the TDS sources are kind of permeate throughout the basin. Also, road de-icers often have salt content, and there are also other forms. We are considering TDS in some detail because it's one of the primary exceedances identified in our analysis of the monitoring data as part of this triennial review. The TDS exceedances are a threat to the continued viability of aquatic biota as we know it. And this is significant for the tribe because if TDS threatens the fish are vital to the Pyramid Lake people and their economy. So we're taking special emphasis on TDS, both in this presentation and in the analysis of the recommendations for future activities. Next slide. In the early 80s, TDS levels were climbing as lake levels dropped, and we'll look at a number of graphs of this in a few slides. But it was the scientists that were working on the lake David Galat and Paul Wagner, who was in charge of the fisheries at Pyramid Lake. They, looking at literature, it became clear that it would be useful to do some experiments to look at the toxicity of TDS specifically towards the organisms that are in Pyramid Lake. And so they, the Bureau of Indian Affairs sponsored a detailed study by Lockheed Ocean Science Laboratory that related, they looked at numerous, a couple dozen species actually of all the various trophic levels, the various types of organisms in the food chain of Pyramid Lake. And they included both the primary producers, such as diatoms and algae, the suspended, the phytoplankton in the lake, and then the consumers of that plant material were studied, as well as the secondary consumers, which are as you go up the food chain, they're the various organisms that feed on the primary consumers, and then we have the fish, the tui chub, which is the dominant fish in terms of biomass in the lake, which is, and then the other fish, of course, the kiwi and the Lahontan cutthroat trout, the top carnivore. So all of these organisms were, or each of these organisms was subjected to or included in the bioassays that were carried out. These experiments were done under ambient summertime temperatures of 18 to 20 degrees centigrade, and the range of TDS that was included in the studies, they started with a reference concentration of 5,839 milligrams per liter, which was the ambient concentration at the time. And then they did some dilutions of that reference concentration, and then up to a 4.5-fold concentration of it in order to provide a range of TDS values. The results were that some organisms were more tolerant of the high TDS than others, and they concluded that because the increase in TDS may affect sensitive species, thereby leading to the degradation of the lake species composition and changes in biological diversity. And so because of this is ecology, the lake, the organisms, if you change one component, it can ripple throughout the entire ecosystem. And so it was deemed that, or concluded that there could be significant impacts on the lake fish populations if the invertebrate food base was altered by elevated TDS. That's from a publication by Galat, 1988. So based on these studies done in the 80s, the standard of 5,900 milligram per liter TDS was selected, and it was included in the initial water quality control plan for the Pyramid Lake tribe that was approved by EPA in 2008. Next slide. So this slide has graphs on the left-hand side of TDS trends in the lake and the river on the right-hand side. We have the time scale in the left-hand set of graphs for the lake starts in 1865. And I'm impressed that there actually are data that go back 150 years for TDS. There are only a few data points, but you can see the trend in TDS is increasing through the century into the 1900s and through up to late 1980s. The red line is the standard of 5,900, and you can see that within the last few years, 2015, in fact, the TDS reached the the standard of 5,900. It was actually just barely under by like 0.1%. These values that are shown here are the annual averages. So you'll see in subsequent slides that there are time periods and locations where the TDS might exceed the standard, yet the annual average would be lower. So you can see the overall increase through time in TDS. These are, if you look at the lower graph, the Pyramid Lake elevation, you see that as the TDS, as the elevation decreased in the lake, TDS went up, and this is due to the concentration effect. Pyramid Lake is a terminal lake, and if you don't continue to evaporation causes the salt content to drop. I'm sorry, salt content to increase as the lake level drops because it's getting more concentrated. You see on that bottom graph on the left side there, Derby Dam diversion. The point where we begin to see this downward trend in TDS occurred concurrently with the beginning of operation of Derby Dam, which diverted what flows from the Truckee River to the Carson River drainage, and this resulted in a dropping of the lake level and an increase in TDS through time. We'll talk more about the time series in a bit. Over on the right-hand side we have TDS in the river. Again, the red dashed line is the standard, and the standard is 310 in the upper part of the Truckee River on the reservation, and you can see in 2015, which was a drought year, low flows led to elevated TDS, which exceeded the standard. Similarly, the downstream plot is several of the stations that are Dead Ox and down to Marble Bluff Dam, and you see the trend is similar, and did show some exceedances of the standard in 2015. Just to give you a feel for what these numbers mean in terms of concentration, a seawater TDS averages about 35,000 milligrams per liter. So Pyramid Lake is about 1/6 the salinity of seawater, and the lake levels at the lake concentrations, let's say rounded off to 6,000. That's about 200 times the concentrations that we see in the river. Just give you a feel for the salinity of the lake. Next slide. So as the lake concentrations have dropped, as lake elevation drops, the volume of the lake has decreased. The left-hand plot shows the time series of from the 1800s until present of lake volume, and you see it decreasing there, similar with lake levels. So it's getting more concentrated. The lake levels are decreasing due to evaporation. There hasn't been sufficient flow to keep the levels up, and so you end up with a relationship in the lower right there between elevation and TDS, where you see at the higher TDSs are associated with higher lake levels. And so let's move on to the next slide. TDS is measured by the tribe fisheries department. They go out and do lake profiling at that station 96 that Aaron mentioned in the middle of the lake, and they use this instrument that has multiple sensors on it, and it's lowered over the side, drops down through the water column, and you get a nice continuous data set of the various constituents that are measured. In this case, we're plotting on the left temperature and on the right TDS in 2016. The depth goes down to 96 meters, which is like 310 feet deep. And you can see here with temperatures, first of all, let me point out that the 2016 was the end of a drought period. And we're going to compare the top two graphs during 2016 with the bottom two that are 2017, which was a high water, high runoff year. And you can see as the depth during the winter time, which is the red plot in March, the water column is nearly equal in temperature all the way down. And then as we go into the warmer part of the year, you start to get an increase in surface temperature. And you get a bend here that's known as the thermocline. The TDS shows first of all, during the winter time, you can see how the green line is exceeding the standard. Black dashed line is the standard. So seasonally, it exceeds the standard all the way down to 70 meters. And then there is during the formation of this lake stratification that occurs, you get decreases in TDS concentration at the point where the temperature is changing quickly with depth. Then in 2017 was a very high runoff year, and it brought a lot of so the high flow entered the lake and ended up diluted the surface water, and you can see that there in June 29th, the beige color, you see quite a difference. So it's around 4,900, where it's like 1,000 milligram per liter less than up at the surface. So I think the point here is that in order to get the data for TDS in the lake, you've got to go through some work. You can't just go out to the end of the dock and dip your sample bottle in the lake water. You have to, at the edge, you have to do a careful analysis. And one other, a couple of other points of this slide is, in addition to temperature and TDS, the tribe has also collected dissolved oxygen, pH, solar radiation, and other parameters as part of this of the profiling work. And also noteworthy is that as the temperatures increase during the summertime, spring and summer, it begins to get into temperatures of 15, 20, 23 degrees. And so the fish tend to swim deeper down into the 30, 40 meter depth, which fishermen are aware of because they use downriggers to get down when they're fishing to the hope of catching fish. So next slide. This is a slide of the inflow to the Pyramid Lake from Truckee River in the total volume, and this is in acre feet, thousands of acre feet, and you can see for this time period, 1956 to last year, there's a lot of variation in the graph from as you go through this time series. And you'll note that there are periods when there's drought conditions. For example, during the early 1990s, you see there's 5 years in a row with low, very low flow into the lake. And this corresponded with periods when the TDS rose because there was so little flow inflow. So in addition to the precipitation patterns and kind of the drought, high precipitation and runoff cycle that is normal in or found in the Truckee River drainage. There are also a number of human factors that have affected these flow rates into Pyramid Lake, and I've listed them in the upper right-hand corner. The thing that started a very important factor, number one importance for the Truckee River on the reservation and the lake. There have been the diversions from Derby Dam that began in 1905. There were a set of operating criteria and procedures that is known as OCAP that was initiated in 1967, and that was the reason for some of the rise in lake level that occurred there in the late 60s that we saw in the prior graph was because of this OCAP. This is relates to Derby Dam diversions to the Newland project from the Truckee River. The OCAP is a very important part of the kind of day-to-day operation of the system in terms of it provides or kind of regulates the flows out from Derby Dam out the canal, and the OCAP also encourages efficient operation of the canal system. So it's an ongoing thing that's quite important. Also, there was a reservoir, a Stampede Reservoir in the upper drainage that was built in 1970, and that was dedicated for fishery enhancement, primarily to facilitate the spawning of the kiwi. So this became a reservoir that served as a source of flow for regulation in the river and supplement for the purposes of the fish. For decades, there's been considerable litigation related to water rights and so on the Truckee River. Some of it, or much of it, originating from the tribe, and also the states of California and Nevada were involved, federal government, and in 1991 there was a settlement act that was important because it provided the permanent allocation of water between the states and the various basins and the tribal water rights. This has had a large effect on being able to actually provide more water beginning in the 90s. And it's when you look at this graph, you can see how there is during the low flow years, there's like 50, 100, 200 that 1,000 acre feet in those drought years that did not occur back in the 60s and 70s because these various agreements were not in place. There was in 2003, there was let me first talk about the water quality agreement. Was federal and actually local funding of $24 million that was used has been used to purchase water rights to supplement flows in the Truckee River, and the overall flow regimes. There was a set of ecosystem flow regimes that came into play in 2003 that we'll be talking about in a minute, that have allowed for increased flows down the Truckee River to Pyramid Lake. And finally, the TROA, the Truckee River Operating Agreement, was finalized and began kind of an overall way to manage the flows beginning in 2015. So basically, wanted to briefly talk about these various acts because it's the reason that there are higher flows, as will be illustrated in the next slide. Go ahead, Aaron. So here we see in the top panel, we have a time period from 1985 to 1990. And in the bottom slide, bottom graph, the time period 2016 to 2021. So we've got 2 6-year periods here. If we look in the top graph, the blue shading allows you to visualize flows that are below 100 CFS, and the red dashed line is at 10 CFS. Note that the flow, the discharge on the y-axis is on a log scale, and you can see how during the 85 to 90 period, nearly all of the years had a flow of less than 100 at the Nixon gauge. And in fact, it got as low as 8 CFS in 1990. And if you compare that with the last 5 years, similar graph, nearly all of the flows were greater than 100 CFS, and the lowest daily average flow was about 90 CFS. And the reason that the flow regime has changed is because of the TROA and the water quality agreement and the availability of or the management of the flows to allow more water to be released into the Truckee River below Derby Dam. Part of this relates to ecosystem flow regimes that I'm going to talk about in the next slide. There is a set of flow recommendations that were initially part of the Lahontan Cutthroat recovery plan that Fish and Wildlife Service released in 1995, and then in 2003, what's called the TRIT, the Truckee River Implementation Team, that was organized by Fish and Wildlife Service. They after much discussion and study, they released a set of recommended ecosystem flow regimes, and these are a tool for decision makers to guide in-stream flows that more closely resemble natural flow conditions, and they're intended to maintain an essential base flow, and so we have a set across the top here of these are like precipitation conditions for a particular year, from very wet to extremely dry, and you can see for the months through the year, January to December, there's a set of flow and CFS there's like a prescribed flow based on the amount of available snowpack and storage in the system, and so these have been designed to allow adequate flow for the river to do its geomorphic work in terms of scouring and moving bed forms when there's adequate flows, such as under these very wet conditions. They're also designed to allow for cottonwood recruitment, fish spawning, and also to maintain the base flow for macroinvertebrates and fish. And that's one of the reasons why, or that it's dictated the increased flow that we observed in the last slide. The idea is to maintain a base flow for that allows for an ecological integrity of the system, and basically, kind of the bottom line on this is if you drop below 100 CFS, it's thought that the during the summertime, that it will damage the riverine ecosystem. So flow is an important part of water quality, of looking at water quality and the suitability of standards. If we go on to the next slide, we just talked about the in wet years when there's adequate flow to allow for the river to kind of do its thing in terms geomorphologically. This gives an example of what occurred at the Truckee River at Wadsworth. The upper photograph it's a meander band, a point bar that shows the early photo taken in early 2000, and you can see the cottonwood trees of various ages, the 20s and 87, 95, and then after in a photograph taken in 2013, after having this flow regime that was possible, you can see how the vegetation has extended to the edge of the point bar. This is the same meander bend, slightly different angle, but you see there's a very impressive riparian forest of cottonwood trees. And what this leads to is enhanced diversity of the hydraulic habitats. In the right-hand diagram here, at the top of the slide is like a channel that's relatively straight, and as if you get more sinuosity, you develop increased hydraulic habitats, and these only can take place when you leave enough sufficient water in the river and don't send it down Derby Dam. Okay, the reason for the improvement in the channel form has been because the water was retained in the river, in the lower river. The various colors on this lower diagram on the right constitute the various types of hydraulic habitats, and they include pools, for example, where the fish can hang out during drought years, where there could be cooler water. So the refugia to allow the biota, the macroinvertebrates, and the fish and so on to withstand drought conditions. It's a healthier river system. Next slide. The reason that I've described this is that the vegetation in the channel, having this diverse riverine habitats, allows for conditions that are kind of healthy in terms of supporting beneficial uses. And these are slides. The left-hand slide is John's Ranch on the Pyramid Lake Reservation, and then the lower slide is Truckee River at Numana, and it just illustrates what you could consider to be a healthy river system. The right-hand slides are from McCarran Ranch, where there was a restoration project, and the restoration results 20 years after the construction that was done there lead to produce a system that has increased assimilative capacity for nutrients, cooler temperatures, and provide excellent conditions for fish. The fishing folks talk about the fishing as being as good as they've ever seen it, or for example, in the Truckee River Reach there at McCarran Ranch. And that's one of the reasons is because of the flows. And the flows have allowed, we move on to the next slide. The flows have allowed the oxygen conditions to improve in the Truckee River. There is a monitoring program by the Pyramid Lake Tribe, Aaron pointed out the two locations where there's continuous monitoring for oxygen. It's and other parameters. This is done with an instrument called a sonde, which measures multiple water quality parameters, such as including temperature, pH, oxygen, turbidity, conductivity. And conductivity is an indirect measure of the TDS concentration. And so this photograph shows the pipe hanging off this suspension bridge in Wadsworth is protecting the sonde, and so it provides a continuous data set for oxygen and temperature, et cetera. So on the next slide, we'll see some data. And what we're looking at here is really related to the health of the river. But measuring oxygen, it's kind of like giving the oxygen and temperature conditions are like provide a direct measure of kind of the way that the extent to which the river is supporting aquatic biota. And so in this slide, we have several days, 2 weeks in July of 2021. And the top graph is dissolved oxygen, with the red line being the standard. Standard is 5 milligrams per liter. We have plots from the Nixon and the Wadsworth monitoring stations. The green one is Nixon on the left there. I'm sorry, Wadsworth is on the left and Nixon is on the right. And you see a kind of a rhythmic pattern here. Each one of these is a day. And the oxygen increases during the daytime due to photosynthesis, falls during the afternoon and night due to respiration. And what's important here is that all of the oxygen levels were above the standard of 5 during at the 2 stations monitored on the reservation during July 2021. Mid-July is kind of the worst case time due to the high temperatures and low flow. So this is really an excellent, it's good news to be able to see that that the oxygen levels are above the standard. The oxygen concentration is affected by various factors that include water depth and velocity. Both of those are related to flow. Okay, one of the reasons these oxygens are above the standard is that the flow, is shown on the bottom graph, is close to or slightly below 90 CFS, but it's not down at like 5 CFS. We used to see in the past, before these maintenance flows were established, like in the 80s and early 90s, we would see oxygens drop down to like 2 milligrams per liter at this station. And so this is excellent that the oxygen levels are higher. The other factors that affect the growth of the periphyte, and periphyte is the material, primarily algae that is present on the surfaces of the rocks on the bottom of the river, so other factors that are affecting the oxygen concentrations include the pressure, how much periphyte there is, and also other aquatic plants and detritus. The level of biomass of periphyte is influenced by flow, but also primarily by nutrients available. And this is the nutrients are set in the water quality standards. And so the fact that the oxygen levels are being maintained properly above the standard reflects that the nutrient standards for the Truckee River are appropriate. It's one of the reasons why there was not a decision to alter the nutrient standards in the river. And also wanted to point out that that part of the in the bed of the river you have insect grazing, and really this is the food chain that produces that big trout that you saw the happy fisherman holding, and that some level of periphyte is, you might say, good in the sense that it helps support the and necessary for what you might think of as a healthy system that is supporting beneficial uses. Let's go ahead to the next slide, Aaron. And what we've done here is to take all of the data that the tribe has collected over the last 4 years using their sondes. And I have one slide here for Wadsworth, and the next slide is going to be at Nixon. And you can see, just let's stay on Wadsworth. I have the red dashed line for dissolved oxygen of 5. This is these are the maximum, the daily maximum dissolved oxygen. What we're most interested in is the center slide, which is the daily minimum. This is the whole year from 1st of January to the end of December for these time periods when we have data over the 4 years. And what's most important is that the oxygen conditions are keeping above that exceedance level of 5, with the exception of one data point here, which may have been a rainstorm. I have to look. But the overall point is that we have attainment of the water quality of the dissolved oxygen standard, and if we look at the flow levels discharge in the lower plot, you can see that during these years the temperature, the flow was nearly always above that level of 100. So one of the reasons why these oxygen levels are being maintained above the standard are that that there's adequate flow, and that the nutrient standards that are in place have been protecting these or allowing the oxygen levels to be above the standard. These observed oxygen conditions are really something to be celebrated. It's the result of the collective efforts of decades of hard work, negotiating adequate flows, channel restoration, non-point source, and upgraded wastewater treatment facilities. There's been a lot of hard work and considerable expense to do all this, but the result is that we have good conditions in terms of oxygen in the lower Truckee River. So the next slide shows farther down the river at Nixon. The trend is very similar. I won't go into much detail here other than to point out the middle graph is their daily minimums. And you can see, with the exception of just a couple days, we're at either close to or above the standard of 5 milligrams per liter. And this is accompanied by, or the flow data also show elevated flows during these summer months when the dissolved oxygen tends to drop. Next slide. So I'll quickly just show the temperature plots. This is from the sondes operating at Wadsworth. The standard for temperature for the daily maximum temperature only extends from January to July and November to December. There's no, and there it's intended to protect the spawning habitat for the fish, both the Kiwi and Mohawk cutthroat. The center slide is the daily average temperatures, and the red dashed line is the standard. So we are seeing exceedances of the temperature standard during the middle of summer at the flows that are shown in the bottom graph. The next slide shows Nixon, very similar data set, slightly higher elevated temperatures. So let's move on to the next slide. That finishes the section on on oxygen, temperature, and flow. And I'd like to talk a little bit to wrap this up here about harmful algal blooms in Pyramid Lake. These tend to occur in late summer, high temperature and periods when there's plenty of phosphorus, ample phosphorus, and there's a bloom of a cyanobacteria that's called nodularia that's been reported over decades to occur in Pyramid Lake. Nodularia is a nitrogen fixing cyanobacteria, and so it doesn't, as long as there's ample phosphorus and warm temperatures, nodularia will grow. And this is we see here a nodularia bloom that occurred in 2020. On the left-hand side picture is an aerial photo of Pyramid Lake, and you can see the patterns of the plant material floating on the surface of the lake. Right-hand picture shows Marina Beach, so very high densities of these harmful algal blooms, and they are of concern because they produce toxins that are toxic to humans, livestock, and it can cause, for example, dog mortality if dog licks its fur, having been covered by the gunk that you see at this on the right-hand slide. So it is the harmful algal blooms. They led to actual closure of the beaches in 2020, and it's something that unfortunately there's very little that can be like done about this, other than trying to keep the nutrient levels low that are the nutrients that are flowing into the Truckee from the Truckee River into the lake. Next slide. We look briefly at as part of our work with the tribes at the potential effects of future climate change on Pyramid Lake. The most recent available published data related to climate change in the Truckee Basin that extends down to Pyramid Lake is from a TUMWA project that was completed in 2020. It was called the Climate Change Analysis, and the TUMWA provided us with the data that we've been looking at data for loads from the Truckee River, not loads, but inflows into Pyramid Lake. And so we've been evaluating that information. Overall, the climate change, I've summarized this in a slide here, where based on the TUMWA report, with respect to climate change, we can expect an increase in the variability of flows in the future, likely temperature increases, which will lead to evaporation increases. Item D, there'll be less precipitation occurring as snow and more rain, and this can lead to snowmelt driven runoff that would occur earlier in the year because it's raining instead of snowing in the wintertime, early spring. And this in turn, item E here is that that floods of higher magnitude and peak flows and high flow events may occur more frequently. So in terms of from the point of view of Pyramid Lake on the next slide, we evaluated the projected flows, and there was a large variation in these projections of the inflows over the 2018 that should be 2097 period, and so what we've we concluded that it needs to be looked at further in terms of the assumptions in the model and the uncertainties. But from the perspective of Pyramid Lake, if the mean annual flows are in fact reduced and lake temperatures rise, these in combination will be expected to lead to increased TDS concentrations. And we've just talked about how we want to do what we can to keep the TDS down. And so we've got to plan to hope for the worst, hope for the best and prepare for the worst. And because of that, our group has recommended that the tribe work with other stakeholders to evaluate the upstream sources of TDS and initiate to reduce the controllable TDS load in the basin where feasible. This is quoted straight out of the Water Quality Control Plan. Next slide. Here are some final recommendations to sum up here. The number one we've just talked about, number related to TDS. We recommend continuing efforts to manage the nutrient loading, which combined with elevated temperatures can stimulate harmful algal blooms. We recommend promoting water conservation and management, which is already ongoing in the basin, to help keep the lower Truckee River flow as high as possible within the other constraints of other water users and so on, and then distribute them according to the fish flow regimes ecosystem flow regimes that were described. Recommend continuing river restoration efforts to improve the habitat diversity. There's also a simulation of nutrients in these healthy restored channels. And this allows the aquatic biota to survive prolonged droughts. Next slide. And finally, with respect to climate change, we recommend collaborating with others on reducing the uncertainty of the future climate change impacts through coordination, monitoring, and additional modeling. With respect to the TDS toxicity to aquatic biota, the studies that were done back in the early 80s, they were limited to data that limited to conditions that were single ranges of ambient temperatures and oxygen. And we are recommending that there be additional studies that look at the interaction among various variables such as TDS, oxygen, and temperature. We just talked about how due to climate change, we may have elevated temperatures. And so it makes sense to update the studies that were done. I'm now going to pass it back to Aaron to wrap up our workshop.
Yeah, Jim, I'll go ahead and I'll talk about these few remaining slides.
Sure.
So during the course of the Triennial review, over internalized data sets, over external data sets, we've found that there were really no changes to the site-specific criteria of Pyramid Lake or the Truckee River that were found during this Triennial review. So we have to recommend that that there are no changes to the established criteria, but we do recommend analyses of metals, of the metal content of the water character on the reservation. We also recommend further study of organic pollutants, including endocrine disrupting compounds. We recommend an anion cation complete analyses, as well as further studies into fish tissue sampling, possibly towards establishing a new subsidence level of consumption. At this time, I want to remind everyone of the public involvement opportunity. We will be hosting a Zoom public hearing on August 2nd, 2022 at 10 a.m. Once again on Zoom. Please visit our website, www.plptwq.org/triennial review. There you can find more information on the triennial review process. You could register to be included in the public hearing on Zoom, and you could find the email address to submit your public comment or question. That email address is plptwaterquality@swca.com. And once again, I want to remind everyone that we are taking public comment until August 3rd, 2022, up until 11:59 p.m. I encourage everyone to submit your public comment or question. Finally, I want to acknowledge the EPA for providing funding for the triennial review process. So thank you, EPA Region 9 office. And that will do it for this public hearing. I want to thank everyone for their participation. I want to thank the attendees for attending, and I once again want to encourage everyone to submit their public comment to the email. And that will do it. I'll send it back to Mandy. Thank you.
All right, thanks, Aaron. So this is intended to be our public comment period. If there are any public comments, please post those in the Q&A or raise your hand. We'll wait just a little bit to give people a chance to provide questions in the Q&A or to raise their hand. And it doesn't look like we're getting any. So I think we can go ahead and end the recording and call it the end.